So in this part, the researchers will pitch their projects. Each of them has only 2 minutes to present. You using Slido can vote on the project you liked the most. The winner receives a Galaxius voucher, as well as a selection of books sponsored by O'Reilly. Before we jump into the presentation, I wanted to thank Magda Kern. So Magda, she is one of the best public speaking coaches in the world. She is also the lead of speakers at TEDx Zurich. So she organized a workshop with our presenters and gave them valuable tips how to present a scientific project in limited time frame. Thank you, Magda. She is also a mentor during our mentorship session. So if you have any questions regarding public speaking or how to build an image as a professional, have a chat with Magda. Okay, now the stage belongs to the researchers.
Okay. Hello, everybody. My name is Crocetti. I'm a PhD student at ETH Zurich, and today I would like to present my work about the development of a global machine learning-based forecasting model about for atmospheric water vapor sensed by global navigation satellite systems. I know this title might sound a bit complicated, however, it's not so hard to understand the concept, because I'm sure that all of you have already been in touch with global navigation satellite systems. How? Well, I assume that all of you have already used your phone to navigate or find your position or find a certain location on the map, like the conference center we are here today. And the principle behind is that satellites in space are sending their signals down to Earth. Here we retrieve these signals, and with the help of those, we can get positions. However, I'm now not really interested in navigating or finding positions, but in atmospheric water vapor. So since the signals are traversing the atmosphere, we can also get some information about the atmosphere. Basically, the signals are getting delayed while they are traversing the atmosphere, and this delay can be measured, which in turn is highly correlated to the amount of water vapor. However, we only get this information at the points where the signal is penetrating the atmosphere. So to make it now really possible to get this information everywhere, so to get the atmospheric water vapor everywhere, I use machine learning techniques. And if you are now curious and would like to know more, then please come later to my poster. Thank you.
Did you know that in a country like Nigeria, up to 40% of fruits and vegetables are lost post-harvest? One of the main reasons is the lack of cold storage, which simply means that farmers harvest their crops, but they don't have a place to store it, and so the crops get spoiled in the heat. Social entrepreneurs have started installing solar-powered cold rooms that farmers can use to store and preserve their crops. However, these enterprises face difficulties in growing and scaling. So that's where we come in. Our initiative focuses on making the cold rooms more accessible for farmers. In doing that, we want to focus on 3 main aspects. The first aspect is business model innovation, which means that farmers just pay a small fee to store their crops in the cold rooms. The second aspect is digitalization, to harness the power of data to make the operations at the cold room more efficient. And the third aspect is capacity building, which means that we are enabling farmers to be fully aware of the benefits of cooling. So jumping right into the digitalization part, we have developed a mobile application that is free to use for the companies and for the farmers that can be used to better manage the operations at these cold rooms. And also the app features models that help the farmers decide when and where they should sell their crops. And this means two things: digital twins of fruits and vegetables that can predict what is the remaining quality of the crops that are stored in the cold rooms, and also machine learning models that help to forecast what are the market prices around the cold rooms. So to date, we have piloted this solution in 19 cold rooms across India, Nigeria, and the Philippines, and we could show that by using the app, the farmers can reduce their losses and increase their revenues. And if you'd like to know more, please stop by at the poster later. Thank you.
Hello, everyone. Hello, everyone. I'm Harpreet Kaur, a PhD student, and I came all the way from New Delhi to Innsbruck to study about bacteria. More specifically, I'm interested in understanding how these intelligent active agents can navigate their environment and forage for nutrients, especially when the position of targets are unknown. And now, some of you might be wondering, why is it so important to understand this bacterial navigation? Well, by developing an understanding of these behavioral strategies, we can hope to design artificial systems that can do a drug delivery in a human body or an environmental remediation, which can significant impact in health and also for the environment. And for my work, I use genetic algorithm known as NEAT. And the basic idea behind is not only the weights are evolving, but also the whole topology of neural network is evolving during the training process. And the questions that I'm trying to understand or to answer are this genetic algorithm able to investigate target search strategies in stochastic system? And what does this strategies look like? What kind of network topology is designed to obtain such strategies? And how the strategy depend on the activity of the particle? To get these exciting answers, please do visit my poster. See you there.
Hello, everyone. My name is Tetiana, and I am an intern at Bern University of Applied Sciences. And today I am excited to share with you our case study on the use of generative AI in art therapy. So art therapy is a form of psychotherapy which helps individuals express their emotions through creative techniques such as drawing. A traditional art therapy works as follows. First, there is an initial conversation when the client express the topic, their emotions, and visual ideas with a therapist. Then the clients start creating an artwork, being mindful of their emotions, and the therapist provide guidance and support for the client. Once the artwork is done, they see what is seen and felt in the image, and if needed, they make changes to improve the artwork. Finally, they have a discussion about how these visual adjustments can be translated into real-world solutions. So in our case study, we use generative AI to enhance this process. And as an original art therapy, we first created an initial artwork that's a person standing at symbolic crossroad of their life, choosing between two different paths. Then, using the techniques like stable diffusion, we enhance the image with adding some stars and clouds to deepen the emotional expression. And finally, at the end, with the use of Inpainting, we can see that we depicted a desired outcome of the therapy. So it's created of one single, bright, hopeful path. By no means we would like to replace the art therapy, but rather to see how generative AI can be used in similar settings. And if you're interested in the topic, I am ready to answer your questions during the poster session. Thank you.
Hello, everyone. I'm Vinitra Swamy, and I'm a machine learning PhD at EPFL. So I'd like to present to you a new architecture for multimodal learning. Right now in multimodal learning, what happens is that we have a lot of different modalities, and they're all mapped to the same shared embedding space. And these are then output for different tasks. And we think that there are some disadvantages with this approach, because especially in low resource settings, you learn patterns from missing modalities that you have in your data. And it's not interpretable. You cannot decompose the modalities and find out which one contributed which parts to your data in a dynamic way. So we present an idea of sequential fusion of modalities with an autoregressive latent space, as shown on the right. And a quick example is, let's say you're a student in an online class, because I really like the education setting a lot. You're watching a video, and this video interaction goes and updates your state. And the state is a general representation of your knowledge as a student. Then let's say you solve some problems on a quiz, and those problems are sent to a problem encoder, taking in your previous state and outputting the next state. And these states are decoded on any number of tasks, as in your performance on the next week, or whether you're going to participate on the forum, anything like this. And in this way, you can find out exactly how much each modality contributes. So I seek to convince you at my poster that MultiModN is composable. It's robust to missingness, so a difference in training and test data modalities doesn't actually impact this architecture. That it's performant in the real world, where we test on education settings, Mimic, which is a healthcare data set, and weather forecasting. And it's actually now used for clinical trials in Africa. It's interpretable by design, and it's easily extended to any number of tasks. And this work is a collaboration from a great group both at EPFL and Yale. Thank you so much.
Good morning, everyone. I'm Navjot, and I'm studying BSc Data Science at University of Applied Science in Windisch. So the air we breathe in, that's sustainable to the earth, to the life on the earth. And air pollution, on the other hand, that's causing millions of deaths annually, as per the latest guidelines report from the World Health Organizations. Energy sector and the industrial processes is just one of the sources leading to the air pollution. Lack of resources and controls means that fly ash or industrial exhaust is released into the atmosphere untreated. So at Aerosol Retention Research Facility in Paul Scherrer Institute, pool scrubbing is studied, where the aerosol-laden air is pushed through the column of liquid, in this process filtering the air. The resulting bubbles in the water column is studied for their properties such as shape, volume, and the surface area. Especially the surface area and volume are important because the amount of aerosols transferred from liquid to air, from air to liquid is directly proportional to the surface area of the bubble. So in order to study these properties for the bubbles, these bubbles must be first reconstructed. And that's where we applied machine learning methods. With these methods, we were able to identify the bubbles and reconstruct them and study these properties of the volume. If you're interested for more details on the solution and the methods that we applied, please drop by at my poster. Thank you so much.